Hello students, good morning. Today we are learning about still simple titration. This is lesson 21. Our last lesson was lesson 20. If I'm not wrong, the last lesson that we have learned, it was lesson 20. So today this lesson is lesson 21. So our lesson 20 we have learned about how to calculate molarity when given the volume and the molarity of one solution and the other solution. When given the molarity, how to get the volume, how to get the volume of that solution when given molarity. The last example that we have seen in lesson 20 was we were having the volume of the base and its molarity. Like sodium hydroxide, we are given the molarity and the volume, and also we were also having the molarity of the sulfuric acid. Then we were calculating the volume of the sulfuric acid. So this one is today that we are learning in lesson 21 today is totally different. It is the reverse. The reverse, in which here there is nothing changed. From the base, everything is the same. From the base, we have still the volume and still the molarity, as we have learned in lesson 20. But the change is here. Instead of molarity that they give us in lesson 20, here lesson 21, we have the volume. Right now, we are looking the molarity. So when you have the volume of one of the solution and the other solution, you have both volume and molarity, how do you get the molarity of the other solution? That's the question. If the two solutions are same, if they could be the same solution like sodium hydroxide, we could use dilution formula. And if this solution is diluted, we could use dilution formula. But the two solutions are different. If the two solutions are different, this is simple titration. So how do you find the molarity of the sulfuric acid in this case? This example says that 30 centimeter cubic of 0.5 of molar of sodium hydroxide was reacted 20 centimeter cubic of sulfuric acid. Calculate part A, the number of moles of the sodium hydroxide. B, the number of moles of the sulfuric acid. C, the molarity of the sulfuric acid. So here in lesson 20, but C, the difference is coming here, but C, lesson 20 we are asked the volume of the sulfuric acid. It was like that. But tonight or today, they are asking us the molarity of sulfuric acid. So how do you find it? First, let us answer part A. Without answering A and B, we cannot find C. So what do we do when we are answering A? This is what you do. Answering A. So we have the molarity, and I told you before that molarity of any given value in terms of volume is equal to 1000. Then we say 0.5 molar, 0.5 moles in terms of volume is equal to 1000 centimeter cubic. This is the molarity. 0.5 molarity of the base is equal to 1000. What about 30 centimeter cubic? 30 centimeter cubic of the base, how many moles will it be equal to? This is the volume used, and the volume used gives us the number of moles used. 0.5 mole times, we multiply 30 centimeter cubic all over 1000 centimeter cubic. So we want to do cancellation. We want to do cancellation. For the cancelling, we cancel centimeter cubic and centimeter cubic. Then we cancel 0 and 0. Then we have 0.5 times 0.5 times 3. Then we multiply 0.5 times 3. Then we divide 100. Then the product is, if I multiply it, the product is 0.015 moles, 0.05 moles of sodium hydroxide solution. So this is the number of moles of sodium hydroxide solution. So part P, let us do part P. Part P, they are asking the number of moles of the sulfuric acid. How do you get it? The number of moles of the sulfuric acid, if you have the moles of the base and you ask it the moles of the other solution, so you get it through mole ratio. You can get it through mole ratio. You react to the two solutions. Sodium hydroxide aqueous plus sulfuric acid aqueous. Then an arrow. The product will be sodium sulfate aqueous plus water. Sodium sulfate plus what? Water liquid. So this is what we have. Sodium sulfate plus water. This is what we have. So when you have such equation, then this reaction is acid reacting base. Acid reacting base, the product is salt plus water. The salt is sodium sulfate here. So the salt is sodium sulfate. We have sodium sulfate. Sulfate here is 2, because sulfate here is 2. Sulfate, sodium is 2. Okay, we need to balance. We need to balance that. We need to balance. Sodium here 1, sodium here 2. Then you put it 2 here. You balance sodium. Then let's balance also sulfur. Sulfur 1 here. Sulfur also 1 here. It's balanced. Okay, let's also balance hydrogen. Hydrogen 2 here. And hydrogen here in the product side we have 2 hydrogen here. Here 2 hydrogen. And here we have 1 hydrogen. Sorry, 2 hydrogen. This 2 is across. Here 2 hydrogen. That means in the product side, in the reactant side, we have 2 hydrogen here and 2 hydrogen, which means 4 hydrogen. So we need to put 2 here to balance it. 2 times 2, 4 hydrogen. Balance. Both the product and reactant side, the hydrogen ions are balanced. Oxygen, let us see the oxygen, the last element, oxygen, 2 oxygen here. And then in the product side, we have 2 oxygen. Balance. Then if you have now, already we have the reactant, the mole ratio of the reactant, we can get it, the mole ratio of the reactant from sodium to sulfuric acid. We don't have any value here, but there is 1 hidden, then 1. How do you calculate it? How do you calculate it? The number of moles of the acid. The number of moles of the acid, this is how we calculate it. The mole ratio of the acid is 2. Is equal to, sorry, the mole ratio of the base, is 2. Then its number of moles is 0.015. So then we say 2 mole ratio of the base is equal to 0.015. What about 1 mole ratio? What about 1 mole ratio? Cross multiplication. Then this is what we do. 1 times, let me not use this part. Let me use this part. Okay, this is what we do. This one is multiplied by this one. 1 times 0.015, 0.15 mole all over 2. Then what do we get? When we divide that, divide by 2, we will get 0.075. 0.0075 moles of sulfuric acid. Sulfuric acid. This is the number of moles of the sulfuric acid used. So, but C, let us go to but C. But C. That was part. That was part. That was part P. So how do we get part C? Part C. Part A, part P, I have already written the equation, then I balance it. The question C is asking here, saying the molarity of the acid. So how do you get the molarity? This is the number of moles of the acid used. How do you get the molarity? This is the number of moles of the acid used to react the base. So we have also the volume of the acid used. The volume of the acid used is also here. This is 20 centimeter cubic of the volume of the acid is used. So this 20 centimeter cubic, which is the volume of the sulfuric acid used, and this number of moles that we have here, that we go through equation, mole ratio, is the same. because both of them are used. So they reacted with the base. So this is what we do, but see, we will say 20 centimeter cubic of the volume of the sulfuric acid used is equal to 0.0075 moles of the acid used. Then molarity in terms of volume is equal to 1000. What about 1000 centimeter cubic? Then that's where we get the molarity. Very simple. Then we'll say we do cross multiplication. We multiply this one and then we multiply x with 20. Then we start this side. 1000 centimeter cubic times 0.0075 mole all over. You multiply this one, then divide by 20. Divide by 20 centimeter cubic. Then we cancel, we do cancellation. Then here we have centimeter cubic and centimeter cubic, they cancel each other. Then this 0 and this 0, it cancels. Then here we have 100 times 0.075 divided by 20 times 100 times 0.0075 divided by 2. We say divided by 2 because we have cancelled 0 with this 0. Then our answer is this. Our molarity therefore is equal to 0.375 molar of sulfuric acid. This is the molarity of sulfuric acid. 0.375 molar of sulfuric acid is used. So that's how you do it step by step. If I summarize, guys, you asked this question is the beginning of simple titration. In the first part, they asked us the number of moles of the base. Simple way. The base, we have the volume and the molarity. So the molarity is equal to 1000. What about 30 centimeter cubic of the volume used? How many moles will it be equal to? Molarity of any given value in terms of volume is equal to 1000. What about this volume? 30. Then you cross multiply. You get 0.015 moles by doing simple calculation using calculator. Now, but P, they asked us the number of moles of the acid. The number of moles of the acid. To get the number of moles of the acid, you write an equation. When you write the equation, then you balance it. You balance it. Simply you do balancing. You balance it. Yes. When you balance the equation, you extract the mole ratio of the equation. You extract the mole ratio of the equation. When you get the mole ratio, this mole ratio is here. We have 2 to 1. By balancing the equation, then we use the mole ratio by saying 2 mole ratio of the base is equal to the number of moles produced. What about 1 mole ratio? Then from there now, you get the number of moles of the acid because you use 1 mole ratio from the acid side. When you get the number of moles of the acid as 0.075, then part C, for you to answer part C, which says the molarity of the acid, then you take the volume of the acid, which is 20 centimeter cubic, is equal to this number of moles that you obtain from the mole ratio. What about 1000? Because 1000 represents the molarity of the acid. Then from there, when you use that calculation, you get the molarity of the acid 0.375 centimeter cubic. So thank you for listening. Please subscribe and share this video. This is lesson 21.